This lecture is about non-experimental quantitative research designs, and I've broken it into two parts. So it kind of extends the discussion about descriptive statistics, but we're going to look deeper at some research designs that depend on these kinds of statistics. There are several things I want you to be able to pull away from this. I want you to be able to describe some of the research designs that fit in this category. And I want you to pay attention in your textbook to survey research and what is written there about it. I don't feel any need to lecture at you about it because your book does a really good job of that. And it also brings up secondary data analysis, which you need to pay attention to. We do a lot of that in educational research because we have these wonderful, rich data sets that exist nationally, internationally, on a state level. And so a lot of researchers, we learn a lot by what they do with those data sets. And it's not data that the researcher has collected. They're using secondary source data. So let me talk first about experimental and non-experimental and review this. This whole section focuses really on the differences between experimental and non-experimental research. There are two big differences, and these lead to a difference in what you can report. The big distinction between the two is how the researcher divides the groups or finds the groups. For research to be considered experimental, the participants must be randomly chosen from a population and randomly assigned to groups. The research is non-experimental if the groups already exist. The second distinction deals with the independent variable. In experimental research, the independent variable is manipulated by the researcher. In other words, the researcher is able to make the quality, level, or existence of the IV different for each group, and the researcher decides that. In non-experimental research, those differences in the independent variable already naturally exist. So, in an experiment, I'm going to randomly assign children to a reading program. In a non-experimental research, I'm going to take groups of children who are already in those different reading programs. And that's the bottom line. As you can imagine, there's a hybrid or quasi-experimental. That means that the groups are not random, but the IV is different in each group, or it's changed by the researcher. Let me give you a fun example. I want to find out if jelly beans will help workers with their productivity. In experimental research, I would randomly select two groups to represent the population of workers. In quasi-experimental, I would choose two groups that already naturally exist. In non-experimental, I would select a group that already eats jelly beans at work and a group that never eats jelly beans at work. In experimental or quasi-experimental research, I would give one group the jelly beans and the other group would not get anything. Now you can see here that the bottom one is my quasi-experimental, where I'm just using groups that already exist. The top one is where I got to choose randomly the groups. The next big difference focuses on how I can interpret my results. So in my experiment, where I was able to randomly pull the groups out, I can say whether or not the jelly beans caused the productivity to go up or down, or I could say how much of an effect they had on the productivity going up and down. In non-experimental, I can't. All I could say is that there's a relationship between those people who've been eating jelly beans at work and their productivity, or I could simply describe the differences in productivity between the two kinds of groups. And then quasi-experimental kind of fits between the two. If I've got good data and this is a well-researched area, I could start to say that, you know, those groups that eat jelly beans, there's definitely a productivity increase there or not. These are some examples of research questions that come out of this kind of research with non-experimental. And you see a lot of these in the education research because it is just simply so difficult to experiment with people. There are reasons, though, that we can't experiment. The most obvious one is that there are variables we simply can't manipulate. We can't manipulate or change somebody's ethnicity or their gender or their age. And there are times when we should not. Studies on like sleep deprivation, for example, or dangerous situations, we have to be very careful with those. Sometimes it's simply impractical. There could be a political cost and there could be financial cost in time, resources, all of those sorts of things to actually grab experimental groups. And when natural groups exist, it just makes the research easier, more cost effective. And if it's done well, we can learn a lot from it. Not everything has to be an experiment. So when you're looking at non-experimental designs, you have to look at the design. Is there a plan and a structure that provides a credible answer to the research question? In other words, have what the experimenters done, the researchers done, actually it flows from the research question to their research design and what they were able to pull in. So look at the purpose of them. Are they trying to describe something, or are they trying to identify relationships, or are they simply suggesting where further investigation is needed? Now, another type of non-experimental design, obviously, deals with time and age. These things happen naturally, so we can't experiment for the ages of kids, for example. And they're often measured as part of both non-experimental and experimental designs. And there are two types of designs or data that are gathered this way. Cross-sectional designs mean that at one point in time, I have different groups and I go in and I grab data from each group and I compare it at one point in time. So at one point in time, I could grab student, teacher, parent opinions, or at one snapshot in time, I could look at elementary and secondary teacher years of experience. So the concerns you need to keep in mind with cross-sectional designs are always, do the groups represent it shouldn't be the sample, but the population and the participants within the groups. And then always keep in mind the effects of other variables at that snapshot in time. You know, state CRT exams are cross-sectional designs if we were to look at them from a research point of view, because on one day we test all of the kids. Longitudinal designs, though, deal with time, and that's where you want to see that there was perhaps a pre-test and a post-test. So we want to show some kind of change that happened over time or with maturity or after an intervention. Longitudinal designs are obviously usually more expensive to run, and you tend to, down under the concerns section, you tend to lose people along the way, and it's very hard to track people time after time after time. When I did in another life, when I did my dissertation, I actually used 3 different tests with students, and so I lost about probably 17 to 20% of the participants over the course of it, which was fine because I had a decent sized sample size. So there are trend studies where you're actually trying to see a pattern along the way. Cohort studies where you follow the same group year after year after year. And then a panel study, is that you track the actual people and follow them along. This chart will help you out as you look at the difference between cross-sectional and longitudinal. And you have to be kind of careful because sometimes researchers will label it longitudinal when it's really cross-sectional. And what I've done here, if I've given you time to kind of read it, is I've taken a topic or a problem like drug use, and I've shown how it's different in a cross-sectional design. In a cross-sectional design, we're going to have several groups, and at one point we're going to survey them. In a longitudinal design, we're going to have one group, and it could be a group that consists of second graders, third graders, fourth graders. Doesn't matter that the group has different people in it. It's one group. And then I've tested them or surveyed them at several points in time. Descriptive designs, let's look at some other types now. There are designs that simply are trying to paint a picture or tell us a story about what's happening out there. And these, if they're quantitative designs, they're using numbers and data to try and show us what's happening. You will see these often as, you'll see measures of central tendency used. These studies will have like the mean and the mode and the standard deviation and graphs to show what's happening. And this is very important when there's a new area to be studied or something has changed drastically. When you critique these kinds of designs, look to make sure that there's no inferences being made from the sample out to a general population, because there was not a random sample drawn. You can't say that your sample represents the population. You need to be careful that in descriptive designs only, there's no inferences about relationships. In part 2, we'll talk again about relationship designs. Look for descriptions of the participants, the instruments, and the procedures. And always be careful that the conclusions aren't being used for policy or decisions. Unfortunately, in the education world, descriptive research is used all the time to drive policies and decisions. We will see that our 5th graders are performing poorly in the CRT on the state level. All we're doing is describing something, and yet policy changes, decisions are made, dollars are spent. These kinds of designs, descriptive designs, don't answer why. What they do is they build a case that could lead to why kinds of questions.